LanceDB is the database for AI. We started because I was at Tubi TV, a streaming company, and my co-founder Lei was at Cruise. And what we saw was that there was so much pain for ML teams when they were working with unstructured data for multimodal AI. And so all of the data infrastructure was not optimized for that.
Hey buddy, welcome back to another episode of How AI is Built. Today we have a very special guest. Chang Xu is one of the original creators of the Pandas library and has been building tools in data and AI for over 2 decades. Now he's building LanceDB, a database optimized for AI with fast random access, limitless cheap storage, and more.
So LanceDB is the database for AI. So we help our users who are generally AI teams looking to build AI applications to manage their data, to do performant billion scale vector search, and also deliver better performance for training, fine tuning, and the whole data infrastructure needs throughout their AI lifecycle.
Yeah, great. And can you tell me your story, how you got actually into building LanceDB and the file format Lance? What was the problem you was actually seeing in your day-to-day life that convinced you to go into the space?
It's very interesting because so much has happened over the last year. We started LanceDB about 2 years ago and working on a related problem, but in a very different form. We started because I was at Tubi TV, a streaming company, and my co-founder Lei was at Cruise. And what we saw was that there was so much pain for ML teams when they were working with unstructured data for multimodal AI. These are like images, videos, audio tracks, PDFs, point clouds, you name it. So that in the new era for machine learning and AI, the data doesn't really fit well into a table. And so all of the data infrastructure was not optimized for that. And our teams just had a terrible time dealing with that in production. So we wanted to create a new generation of data infrastructure that makes their lives a lot easier. And this is really informed by my experience in open source. So I've been building data tools for machine learning engineers and data scientists for almost 2 decades at this point. I was one of the original creators of the Pandas library. And this is kind of my passion is I love creating a tool and seeing the users get like a 10x boost in productivity or just getting superpowers. That's what makes me happy. And so we wanted to do that for this new generation of multimodal AI applications.
Yeah, and that's especially like the big trend at the moment I'm seeing as well in the data space. There are so many libraries popping up, which are streamlining so much of the process and which are actually focused on improving the performance so much. And most of them are actually based on Rust, like you are. What was the decision to actually jump onto the Rust train?
Yeah. So our Rust pill moment was the end of 2022. So we had spent a good portion of 2022 in C++ writing the core Lance columnar format. And this was used by our early customers, mostly in autonomous vehicles, to manage petabyte scale vision datasets. And one of the things, well, more than one, with C++, our frustrations were it was very easy to write unsafe code that creates segfaults in production when you run it. It's really, really difficult to wrestle with CMake. And overall, it was just difficult to move very quickly and be very agile. And the Christmas of 2022, we were sort of just having a hackathon project for a customer demo. And we said, hey, let's learn Rust. So we wrote that and we were just amazed by how productive we are, how easy the tooling ecosystem was, and how confident it made us feel because the code that we wrote was so safe. And so as a Christmas present to ourselves, we decided to say, hey, let's make a big bet on Rust, ditch all of our C++ code and rewrite it all in Rust. And so we did that in the new year. And it took us about, I think, 3 weeks to rewrite roughly 5 months of C++ development and as like learners, beginners in Rust. So, and I think that's not a unique story to us. So like I've heard from a lot of friends who are rewriting things in Rust that they were able to just move a lot faster because of the language.
Do you see actually more companies which are implementing AI and not really developing like the infrastructure, the libraries for it, switching to Rust as well? Or do you see Rust rather as a support language for something like Python, where a lot of the libraries are actually implemented in Rust and you use it in Python just for the ease of use?
I think in terms of number of users, we will still see the largest usage in Python, just because the Python ecosystem for AI is so rich and has so much tradition. But we're starting to see a lot of the AI application or AI infrastructure companies use Rust under the hood for their systems and services. And as that happens, a richer Rust ecosystem is also coming up so that a lot of these systems can now talk to each other directly in Rust rather than having to use pure gRPC HTTP protocols or have to go through the Python layer.
Yeah, great. And now jumping back into LanceDB and Lance, what are the major components for the developer when he's interacting with LanceDB and when he is actually using the library for basically data insertion, but also vector search?
So for LanceDB, we built that around our core Lance format. Essentially, when users are interacting with LanceDB, they are interacting with either the Python, the Rust, or the JavaScript APIs, and they're sort of talking to a query layer that then wraps around Lance format. And so we try to build it so that it feels very familiar to users who are used to using the usual data tools, especially in Python. So, for example, you can insert data into LanceDB using Panda's data frames, Polar's data frames. You can plug Lance into, let's say, like a Spark cluster, and you can write massive amounts of data very quickly. We have one user that tells us they have a 10 trillion token data set that they're writing into Lance in a massive Spark cluster. And so from small local experiments with pandas to really large embed the internet kind of workflows, if you're used to the sort of traditional Python toolchain for working with data, it's very easy for you to work with LanceDB. And I think one of the interesting things that I feel personally pretty passionate about developing LanceDB is we're big believers in the composable data systems vision. So my co-founder from my previous startup, Wes McKinney, he really made this popular when he was at Voltron Data. And so the idea was the database is going to get blown up. In each layer, we're going to have really great open source projects that make it easy to talk to each other. And you can now easily create very customized data systems by just picking and choosing the right projects and putting them in the right package. And so we sort of follow that philosophy so that our internal query engine, for example, we use Data Fusion. We use Apache Arrow as the in-memory API into the rest of the ecosystem. And so automatically we're getting compatibility with dozens of tools that have integrated with Arrow already.
Yeah. And I just listened to a podcast with Wes McKinney right before we jumped onto the call. And he was talking about the same thing, actually, about the integration of, for example, like pandas now into the Apache Arrow ecosystem and what performance gains they had of using the new string format in pandas as opposed to the Python object. And also what he's building in Ebis tools is really interesting.
Nice. Was that the Costas's podcast?
No, on Real Python.
Oh, okay. Got it.
It actually came out, like, I think 3 hours ago. And looking especially below the hood, if I'm looking at databases often, it's like you have a pretty fixed process. So first I have like data modeling and defining a schema. Then I'm setting up the database. And then I'm actually inserting the data based on the schema. And then I can start querying. What do these components look like in LanceDB?
Kind of under the hood, the schema is Arrow schema, is everything in the interaction is Arrow. But one of the things that we've integrated into LanceDB that I think is really helpful for our users is pedantic. So Arrow is great for infrastructure, but as a user-facing tool, the API is not necessarily intuitive all the time, to put it lightly. And so what we do is we actually allow you to create the data model using a pedantic model. And we take care of the conversion from pedantic to Arrow. So when you create a table, it's very easy in Python to say, I'm going to, I don't really know what the Arrow types and all that are, but it's very easy for me to just create a class that inherits from pedantic base model, and I can use that as the schema. And then I can also just pass in object instances directly into LanceDB, and it knows to translate that into the database schema. And additionally, what Pedantic allows us to do, we've got this embedding registry functionality that allows you to say, hey, this column or this Pedantic field is the vector column, and it's going to be generated using OpenAI or sentence transformers out of this source attribute in the same Pedantic schema. So once you do that, when you create the table, you now no longer need to do embedding generation, either when you insert data or when you query the database. So now, instead of this sort of simple vector search tool, we can now give LanceDB as a search backend, a more generalized search backend for our users. So they can just throw in text or throw in images, and they can add in text embedding functions, image embedding functions, text image multimodal embedding functions. And it's very easy for them to say, I want to query vectors or I want to query keywords, and they don't have to deal with most of the details under the hood.
Yeah. And what other indexes do you support in Lance? So because Postgres is particularly known of having like a shit ton of support for different data types, how is it looking for Lance? So do you also have like geographical data types which you can query, or date times?
So date times, definitely, we have support for that. We generally support most of the arrow data types, and we have rich semantic types on top of that. So for example, we have a semantic type for vector, and the storage is fixed size list. We have semantic types for tensors and images, and we're making one for video as well. So I think the type ecosystem is very rich in Lance. And what's interesting, I think, is when you bring up the type ecosystem, is that Lance is a little bit different from other vector databases in that we let users actually store the raw data, and especially the training data. So we have some of our largest customers, right, storing like petabytes of image data for training in the same data set that they're storing the vectors for serving. So this gives them that single source of truth, so that they don't have to keeping two data sets in sync with each other and things like that.
Yeah. And you have on your website, actually, the phrase which I really love is like up to 1,000 times faster than per K. What is the main optimizations you actually do below the hood to get that performance benefit?
So, all benchmarks are wrong, but some are useful, right? So the whole overall context on that 1,000 time claim is, for machine learning and AI, a lot of times dealing with the data means you need very fast random access. So this is useful for indexing when you do shuffling or sampling and things like that. And so when you want to fetch a small number of rows scattered throughout your data set, that's when we can get up to that 1,000 times speed of Parquet. And then I think the reason why we're able to achieve that with the format is because we lay out the data differently from Parquet. The IO plan for the data set is also different. And we've updated a lot of the access assumptions based on more modern storage technologies, right? Parquet was designed 10 years ago, and storage technologies were very different then, especially there wasn't as prevalent usage of cloud-based object storage, for example, and NVMe SSDs weren't really around, weren't nearly as fast. So by doing all three of those things, we can achieve very, very meaningful performance gains.
Yeah. And when I'm looking especially at the Lakehouse ecosystem as well, they are also trying to basically abstract away the complete storage element from the user and do all of the different optimizations below the hood. And especially in Delta Table, I think what's prevalent now, or what's coming, is liquid clustering, is what I call it, I think, where they try to group the similar elements which are likely to be retrieved together, where they try to group it together. Have you considered such optimizations as well?
Yeah, so we've added stats-based pruning in the format already. So typically the use cases for these types of things are just for much faster filtering under the hood. And on top of that, because we actually support fast random access, it's easy to then attach an index for that. So that increases filtering performance even more, especially if your filters are very selective. So I know that like Delta under the hood uses Parquet for storage, and same with Iceberg and Hoodie. In those types of use cases, Lance is going to be much faster because the file format is different under the hood.
Yeah. And looking at Delta Table, Iceberg, and Hoodie, what would be use cases where you would go like with more of the old formats over Lance?
For now, if you have very traditional BI use cases where the vast majority of your workload is just scanning one column for filtering and then scanning another column to compute some aggregate, and these are like just tabular data columns, then there's probably not a compelling reason to switch. And if you're already in those ecosystems, there's not a compelling reason to switch out for those use cases. So I would say that. And Lance is as good in performance as Parquet, and the systems built on Parquet for those types of use cases. But Lance is much more optimized if you're working with embeddings, if you're working with images and large blob data.
Yeah. And what we already touched upon is like the multimodal part. And this is particularly interesting, especially getting into more and more of the multimodal models, what we are seeing right now. And what use cases do you think LanceDB will enable in the future through this multimodal storage and the associated embeddings, which are all stored in one place together?
So I think we're seeing a lot of these use cases in a nascent form already. So I think one is being able to quickly train models for multimodal use cases. So for example, you get in your car and you can point to one of the windows, say roll down that window, or turn on the radio and play something I like. Or when with AR and mixed reality, also with different attempts at glasses and vision, I think there's a lot of room for those types of applications. Now, the interesting thing is, this is where I think multimodal models, especially like vision models, are very different from large language models, because in production, the language that you see is pretty similar in distribution to the language that LLMs are trained on. But for vision models, that's not necessarily the case. Like large vision models by default are trained on, I don't know, like stock images or something like that, right? Or like Coco or ImageNet or whatnot. But in production, there's no control over that. If you're using that in a chip manufacturer, they're all going to be top-down images of like your board. If you're using them for autonomous vehicles, they're all going to be street scenes, and you're going to be picking out very specific classes of things. And so I think for multimodal AI, there's going to be a lot bigger need to at least fine tune your own model, if not completely retrain it. And so the need for data storage and data management then becomes much bigger. And so I think along with that, for AI in production, I think a lot of the success factors are going to be the same as sort of classical ML. It makes me feel really weird to think classical ML is like 2 years old, or maybe like 1.5 years old, right? But here we are. And I think the biggest thing that I learned from Tubi was that machine learning, generally AI success, depends on the speed at which you can iterate and experiment. And so having something like Lance gives you a lot of advantages. So for example, one of our users told us, hey, I've got 100 terabytes of image and video data in S3. When we want to run an experiment, we have to download all of that data, create the new feature data as a new column, add that into the new copy, and then upload it back into S3 as a new copy. And so this makes it incredibly expensive. And also, it takes incredibly long to run every new experiment. But instead, with Lance, you can keep that same copy and you don't have to load it anywhere. You just write new feature data as new columns directly onto S3, and you can roll back in time. So you can discard experiments that have completed and you won't roll out into production. So I think use cases like these are what I'm really looking forward to helping our customers and users do in 2024 and 2025.
Moving on, you have a few use cases, especially listed on your platform, which are RAG, which is the obvious one, let's say, and search.
Right.
And one I'm particularly interested in is the recommendation systems use case, because I think in the near future, we will see more and more of people realizing that most of the stuff we are doing with LLMs at the moment is recommendation system, especially in RAG. We're recommending the right pieces of content. But also with the trend of shifting the computation to inference time, that we generate multiple different options as answers, as texts, where you in the end have to put a recommendation system on top of that, which answer is the most relevant. I think we will see more and more of that. And I'm really curious, how would you set up the typical recommendation system data model, like having items, having users, and then having the analytics? How would you set this up in LanceDB?
So let's talk about what's similar. So the problem is you want production quality retrieval that is tailored towards our target, right, in both. And so the way that Rexus solves it is you have a first pass recall step that uses a bunch of different retrieval techniques to get relevant data. Then you put them all together and you pass them through a re-ranking model to do fine-grained re-ranking. And then you present that results to the user, usually in either some sort of feed format or some grid format, depending on if you're talking about news or streaming or e-commerce or things like that. And then what's really interesting about Rexus is, of course, you can take that user feedback and you can now fine tune your system. You can change your recaller models, you can change your re-ranker models, and you can add additional business logic rules to change the rankings in a non-machine learning context. Now, with RAG, so far it looks much simpler than that, right? We just say there's a recaller step. Typically, most people are just using vector search, so a single recaller. There's no real re-ranking, but we just feed the results into that LLM query. Now, when people go into production, what they're looking for is, okay, vector search gets me maybe 60 or 70% of the actual results that I want from my knowledge base. How do I do better, right? I need to get to maybe 90% in order for my application to feel production quality to my users. So now we have a lot more experiments in production around, okay, instead of just vector search, you can now add keyword search, you can do SQL queries, or even add like graph databases or something like that. And so now you have multiple recall results. Now you need a way to combine them and re-rank them. And of course, I think the new term is now rank fusion, which it's basically just re-ranking. And then you're presenting the results to the LLM. So it's really starting to look very similar. And what's missing is that feedback cycle of, okay, can I take user feedback and can I fine tune the embedding model, for example? Can I fine tune the re-ranking model? And I think in LanceDB, we're working on that closing that loop in a more automated fashion. A lot of our users today are doing that themselves, and we want to make that easier. We recently released a much more complete workflow for hybrid search and re-ranking. So I think soon we'll have this sort of complete story and it'll look very similar. Now, there are, I think, some important differences, right? Because when you talked about Rexus earlier, you mentioned, hey, we have users and items and analytics, and we're recommending the items to the users. Well, the issue with LLMs is you're not recommending results to a user. You're actually recommending results to a query. Even if they're issued by the same user, different results are going to be relevant for different queries, even if by the same user. And I've been discussing this with a friend of mine, Brian Bishop. So any insight that sounds interesting is probably coming from him and not me. It's only secondhand. So the systems won't look exactly the same, right? You won't have this like really simple users item dichotomy, and it's going to be much more sophisticated, but at a high level it does look very similar.
Yeah, and I think what's already pretty pronounced in recommendation system, you always have a secondary storage at least for the embeddings because they tend to get quite large, which Lance seems to be like at the moment for me the most suited option. And also, it's just your answer right now, just treating LLMs in the end as users might also be an interesting thing. I would love now to go into the code and create user profiles for the different LLMs and just play around with that.
That would be interesting.
Yeah,
Yeah.
that would be really interesting. So at the moment, it sounds rather like heavily on the item-based, content-based filtering, which basically is the RAG. I would really be curious, like, would you envision a future where you also do user-based, content-based filtering or even collaborative filtering? How would you integrate this into Lance if you would want to enable this more?
So with collaborative filtering, essentially what you end up doing is you end up generating the embeddings for users and items that way. So if we're generating like item embeddings using an OpenAI or some embedding model, you probably won't need something like collaborative filtering or these traditional techniques, Rexus techniques, but you still will have item embeddings. Now, it's not clear to me what the user embeddings will look like, but I could envision a future where the results, the way that we recall results and the way that we re-rank them can differ based on the user. And typically this would involve some sort of feedback mechanism that allows us to estimate a distribution for given users based on what types of questions they tend to ask, what types of responses are more relevant to them, and things like that. So we haven't done all the work to test that out yet. So this is all sort of speculation at the moment.
Yeah. And can you tell me, like, what is the most surprising, interesting, unexpected way Lens is used in production right now you've seen so far?
In retrospect, not surprising, but when they were presented to me, it was very novel. It made me say, huh, I didn't think of that. So there are a couple of desktop applications that use Electron that now use LanceDB, and they have local vector storage, and some of them have even local LLM or make a chat GPT call or something like that. And so that was very interesting when we set out to make the data format and the vector DB. We hadn't even thought about desktop applications in a long time, but it seemed very useful and it was great. I think there were sort of lots of rough edges, especially around Windows distributions that we've ironed out. And there's some issues that we probably still needs to fix. So for those guys who've built on top of LanceDB, thanks for your patience. So that's one class of applications that's been really interesting. Another type is actually, we've had a couple of newer machine learning frameworks that are now building on top of Lance format. And the particular one was very interesting. There's a framework called Sapien ML out of Fujitsu in Japan. And when I talked with those guys, their goal is to use Lance not just for the data storage, but when they train models and when they create new model artifacts, they actually want to store the models in LanceDB as well. And what's interesting for them is one, LanceDB is automatically versioned. So as you accumulate more artifacts, it's very easy for them to manage the different versions. And that's one. Two is they can keep the models with their metadata as part of Lance and be able to work with that easily. And then number three is once they've stored it in Lance, they're still trying to figure this part out, but you can create an embedding out of the metadata of that model. And now you have a model database that is semantically searchable. So their users can come into the system and say, I want to compute. I think they're saying like, I want to solve this classification problem using these kinds of data, and they'll be able to essentially recommend the right models to their users using Lance as sort of that search backend. And the interesting thing that we're still trying to figure out with them is, what is the right thing to embed to make these model artifacts searchable? Like if it's a description, how do you make sure their users are actually putting in useful descriptions? If it's something else like a code artifact, what are the relevant things that will support semantic search like that?
Yeah, that's really
So
interesting.
that was also very surprising and very interesting. And I think this is something that makes me think LanceDB might be really useful for agents in the future as well. So if you have agents that starts to collect lots of different capabilities, you don't want to say, okay, my agent knows how to do 100 things. I'm going to send them all to ChatGPT function calls as context and get something back. You want to pick the most relevant few and send that to ChatGPT. And this is where I think LanceDB can come in as a semantically searchable function registry for agents, if you will.
Yeah, like we've seen in the Voyager paper, where they're also embedding the actions the agents learned. Nice. So what tool would you love to see being built on top or next to Lance, which would make it even more powerful?
What I'm looking forward to immediately is bigger integrations into the data ecosystem. And so we want to enable our users to not have to think about that whole data preparation pipeline and ecosystem and all those tasks, and be able to think, okay, I can just throw data and LanceDB, and then on the other end, I'm going to be able to run search results. So small to large data systems being connected at a native level. I think that's really excites me, is to get more data in. And I think I'd love to see, going back to that agentic workflow, we now have some users that are like a very domain specific multi-agentic workflow that they're trying to push into production. So I think it would be pretty amazing to work with them to build sort of these semantically searchable function registries and capabilities into LanceDB. So I think, RAG, we've done a lot of that in the past year. And, I think everybody's probably sick of chatbots by now. And multimodal and agents are the sort of next frontier. And so I'm really looking forward to seeing what our users will build on top of LanceDB in those areas.
Yeah. And like the first point really gave me an idea, like building a foreign data wrapper from Postgres into LanceDB would be a really interesting thing, especially for recommendation systems, where you can take advantage of the structure of Postgres, which makes it really suitable, like the relational data model for the data type for recommendation systems, but taking advantage of LanceDB for the storage of the embeddings and the calculation of the similarity. So what's next for LanceDB?
The next thing on LanceDB is, continue to optimize our scale and performance and ease of use for users. And I think start to deliver on a lot of the topics that we talked about today, of how to make it easy for folks to create a Rexus in RAG, how to make it easier for people to embed the internet and quickly ingest that and index that and make that searchable. So I think a lot of that is driven by the fact that, hey, this year AI teams and individual developers are really trying to seriously build generative AI applications in production. And so how do we serve the needs that are different in production that weren't really a problem last year when it was mostly like demos and POCs?
Yeah. So where can people follow along with you and with LanceDB?
I'd love to chat with folks on Twitter or GitHub. It's the same handle I've had for 25 years, I think, which is Chengiz Khan. And we have a Discord community for LanceDB, and it's pretty active. And there are lots of really interesting applications and use cases that you can see in there. I'd love to talk shop on Discord or on Twitter, or if they just want to ping me privately, I'm chung@lancedb.com.